A 75 milliliter solution of HCl with an unknown concentration is titrated to the equivalence point with 27.3 milliliters and a concentration of 0.157 CaOH2. What was the concentration of HCl in the original solution? Before solving the problem, you should evaluate what is given. 75 milliliters of HCl in an unknown concentration and 27.3 milliliters with a concentration of 0.157 molarity of CaOH2 is also given. The first thing you should do is write out everything given to you in the equation. HCl gives you the volume, which is 75 milliliters, but an unknown concentration. CaOH2 gives you a volume of 27.3 milliliters and a concentration of 0.157 molarity. The first step to solving this equation is to write a balanced equation. This is a common mistake most students forget to use, but is very crucial in this equation. So we're going to take the two reactants, which are given to us in the problem, HCl and CaOH2. And to get our products, we take the positive and the negative from each one, which is OH and H to get this, and Ca and Cl to get this. Our next step is to actually balance the equation. So over here we have two Cl's, but only one here. So we're going to have to put a 2. We have one Ca and one Ca, which balances that. We have two H's and two O's. But you can't forget about this H, so that makes 3 H's. We only have 2 on this side and 1 O. So we're going to add a 2 here, which makes 4 H's, 2 O's, 2 O's, 2 H's, plus 2 H's is 4 H's, which completely balances the equation. The next step to solving this problem is to draw two pictures. In this box, we have HCl with a volume of 75 milliliters, which was given in the problem, and in this box, we have CaOH2 with a volume of 27.3 milliliters, which was also given in the problem. We also have the concentration of 0.157 molarity of CaOH2, but we have no concentration for this one, an unknown concentration for this one. So now we're going to put the elements in the box. So we have H plus, Cl minus, H plus, and Cl minus. In this one, we have Ca2 plus and an OH minus, also another OH minus, which is a common mistake often people make. They forget about the 2 right here and only put 1 OH when there needs to be 2. Our next step is to find the moles of CaOH2. We use the equation molarity equals moles over volume and rearrange it to have moles equals molarity times volume. Don't forget that capital M is different than the moles. We are given the molarity and volume in the equation above, so we're going to plug 0.157 molarity times volume, which is 27.3 milliliters. A common mistake people forget to do is to change milliliters to liters. So we are going to change it to 0.0273 liters. After changing the volume from milliliters to liters, you're going to multiply the molarity, which is 0.157, times 0.0273 to get 0.00429 moles of CaOH2. Our next step is to find the moles of HCl after we have already found the moles of CaOH2. So we're going to use the mole-to-mole ratio by doing moles of CaOH2, which we just found, divided by the moles of CaOH2 given to us in the balanced equation over the moles of HCl given also in the balanced equation to get the total moles of HCl. Now, all we're going to do is plug the numbers in that we found. First, we're going to take the moles of CaOH2 that we found and plug that in right here. Next, we're going to look to our balanced equation and see that HCl has 2 moles and plug that in right there. Next, we're going to look at our balanced equation again to find that CaOH2 has 1 mole and plug that in there. Once we plug all those numbers into the calculator, we get the result of 0.00858 moles of HCl. The final step to this equation is to find the unknown concentration of HCl. We're going to use the concentration equation, which is molarity equals moles over volume. We're going to use the moles we just found, 0.00858 moles of HCl, over the volume given to us in the original equation, 75 milliliters, but remember, we're going to change it to liters, so 0.075 liters, and that gives us 0.1144 molarity of HCl, which concludes this titration problem.